Section 2.5 in college algebra is about transformations. Okay? Transformations are not something I think that we need to take a whole long time on because of how much time we took on them in Algebra 2. Okay? So I just want to remind you in general what's happening. If we have f of x is our main function, and then we have f of x plus 5, what kind of transformation is happening? Vertical shift up 5. Remember that? If we have f of x and then we go to f of x plus 2, what's happening? Horizontal shift, which direction? Left 2, right? Remember that? It's opposite of what we think because it's inside the function. If we have f of x and then we have 2 f of x, what's that causing? Vertical stretch, and we usually say by a factor of 2, right? By a factor of 2. Start with f of x and we say f of 2x. Now this is not one that we really talked about too much in Algebra 2. Where is this 2? It's on the inside of the function, so what kind of change is that? That's a horizontal change, right? So is it going to be a horizontal stretch or a compression? Think about what happens when in horizontal. It's opposite of what we think, right? So we thought this should go to the right 2, but we know it's opposite, so it went to the left 2. We think that since it's a 2, it should be a stretch, but we know it's opposite of that, right? This should be a compression. By what factor, though? One half. So I said opposite a second ago. That was the wrong word, wasn't it? What word should I have used? Reciprocal, right? Okay. Any questions so far? Okay, what about this? We start with this function and then we're given negative f of x. Reflection. Over or across which one? It's outside, so that it causes a vertical change. X-axis, right? X-axis. So if we start with f of x and we get f of negative x, what is that then? Okay with that? So we know if it's outside being added or subtracted, we know it's a vertical shift. Added is up, subtracted is down. We know if it's inside, that's a horizontal change. If it's being added or subtracted, that's a shift. And it's opposite of what we think. So we think it should be right 2 because it's positive 2. We know it's left 2. Okay? If it's a multiplier, this is outside, so it's causing a vertical change. It's greater than 1, so it's a stretch, and it's a factor of whatever that number is. Okay? If it's inside, it's different than what we think. We know it's going to be a horizontal change. It's greater than 1, so we think it should be a stretch, but we know it's different than that. It's the other one than we think. So it's not a stretch, it's a compression by a factor of whatever the reciprocal of that number is. Okay? If the negative's on the outside of the function, we know that is a vertical change. So it's reflecting over the x-axis, it's changing vertically this way. If the negative is inside the function, that's a reflection over the y-axis. You okay with that? Any questions so far? Good. I knew you would remember most of this. Let me rephrase that. I hoped you would remember most of this. Okay. It even goes so far, you guys even know that it even goes so far that even if it's something you've never seen before, like if this happens to be my function, x to the 9th. Have you ever seen an x to the 9th graphed before? No. But if I told you g of x was negative 2x to the ninth minus 7, could you tell me the transformations of that graph? You can, right? You know that it reflects over the x-axis, has a vertical stretch by a factor of 2, and it shifts down 7, right? So what if my g of x looks like this? Have you ever seen that before? No? Tell me the transformations, though. What's the parent, do you think? I and t? Okay, so if I and t is the parent, then what does this cause? Stretch by a factor of 3, vertical stretch, right? And then it shifted left 4, right? Let me show you what this graph looks like because, let's see, let's write it this way. I want to show you what that graph looks like because it does show up on your homework. Okay, I want you to be familiar with it before you get there. What do you think this means? God bless you. What do you think that means? What math word starts with INT? That's one of them. That's a good guess. What'd you say? Same thing as her? Okay. What other math word starts with INT? What type of number starts with INT? Integer, right? An integer starts with INT. And so if x is 0, what's the integer? 0, right? If x is 1, what's the integer? 1. If x is 2, what's the integer? 2. That's not the issue. It's all the stuff in between, right? What if x is 0.5? What's the integer that's closest to that? Like less than or equal to that? It's 0, isn't it? So it starts at 0 and goes all the way to 1, except what happens at 1? It's 1, right? What is 1.2? What's the integer that's closest to 1.2? 1. And it goes all the way to 2, where it is 2. So when this function is actually graphed, it looks like this. What does it look like to you? Use your imagination. Any imagination? What does that look like? Stairs? That's why it's called a step function. Okay? Because it looks like you're stepping up every time you go up. Okay? But like I said, this shows up on your homework. It's not hard. It's not asking you to graph this or anything. It's saying, if this is the parent, what happens here? And this is not something we've ever seen before, so I thought I would just show it to you real quick. You okay with that? Okay. Any questions about transformations? Okay. We did a lot of transformations of parent functions in Algebra 2. We did not do transformations of things like this very often. Again, we did them, but very rarely. Okay? What if I ask you, could you do a transformation on this? Could you do a vertical shift up 2 and a horizontal shift right 3? How would you do that? By moving the entire shape up 2 and right 3, right? Could you stretch it? If this went over 2 and up 1, 2, 3, 4, and I said I need a vertical stretch by a factor of 2, it would go over 2 up and up how many? 8, right? For vertical stretch by a factor of 2, the x's are staying the same. It's the y's that are changing, right? So where would this point be? Exactly where it is, right? Because the x is 0, x is negative 4, y is 0, so y's in that case don't change at all. What about this point? Where would it be? Same point. What about this point? So it would still go over 3, but it would go down 6. And what about this point? Okay, do you have any questions about that? That's something pretty simple, but again, I want to make sure you have been exposed to all these things that you're going to be asked to do for homework. Okay, we did some of these in Algebra 2, just not a lot, and I just want to remind you about them. Okay? Okay, here's the big part of the lesson. Okay, the big part of the lesson is section 2.6. And section 2.6 has to do with combinations of functions. Okay? Combinations of functions you have done. I'm not worried about combinations. I will show you a couple of examples though, so you understand what's going on. we have f of x, and we'll say f of x is 2x plus 5. And I'll tell you that g of x, excuse me, is x squared plus 3. Okay? So combinations of functions say, I want you to tell me f plus g of x. And it looks like that. What f plus g of x actually means is take f of x and add g of x. Is that hard? No, but I needed to remind you because it's been a while since we've done it. Okay? What is f of x in this case? 2x plus 5. What is g of x in this case? X squared plus 3. So, what's the answer? X squared plus 2x plus 8. Any questions about that? What's the domain of this function? What type of function is this? Let me ask you that first. Linear, right? What's the type of function is this? Quadratic. Linear and quadratic, you know both of the domains are what? All real numbers, right? You remember that? Okay. Line looks like this. It goes all the directions, left and right. This quadratic would be like a parent function that shifted up 3. So either way, it's still going all the way left and all the way right. So it's all real numbers. What happens to the domain when I add those two together? Domain is still all real numbers. Does that make sense? Okay. So you also have to know f minus g. Combinations of functions can be subtraction. So that literally means f of x minus g of x. Well, f of x, what if I said g plus f of x? G of x plus f of x, would that give me the same answer as this one? You're right, because it doesn't matter what order we add in, right? F of x minus g of x and g of x minus f of x, will those be the same answers? No, they won't, because it matters what order you subtract in, right? So just be careful making sure you know about the order. F of x is 2x plus 5 minus g of x, which is x squared plus 3. So I have 2x plus 5 minus x squared minus 3, don't I? What do I get here? Negative x squared plus 2x plus 2. You okay with that? What's the domain of this function? Well, it's flipped over this way, isn't it? But isn't it still all real numbers? You are correct. Okay? F g of x. What's it wanting me to do now? Multiply f of x times g of x. F of x is 2x plus 5. G of x is x squared plus 3. And how do we multiply this? Distribute. I'm so proud of you because I have to let you know, if you look in your book, it wants you to FOIL this. You know how I feel about that, right? FOIL is what we do when we're little babies. And it's fine to learn, but when you get to Algebra 2 and higher, you don't always just have two binomials. So I'd rather you know the correct vocabulary. Distribute. 2x to the third. Distribute. Plus 6x. Distribute. Plus 5x squared. Distribute. Plus 15. So if we were worried about standard form, which we may or may not be, it'll probably tell you one way or the other. Okay? 2x to the third plus 5x squared plus 6x plus 15. What is the domain of that function? It's a cubic. Do you remember what shape a cubic is? Like that? Probably not exactly like that, but close, right? What's its domain? All real numbers. F over g of x. What's it want us to do? Can I change it just for argument's sake? Are you okay with that, me changing it? What if I did g over f? Well, g would be x squared plus 3. X would be 2x plus 5. This is the hardest one because it's done. Right? And by that I mean it's not hard at all because it's done. Okay? Now you might sometimes have to factor out a common term and factor those terms out from numerator and denominator, right? But what's the domain of this function? Dun dun dun! This is where it changes, right? When we have a rational function like this, what is the denominator not allowed to equal? 0. Okay? So far, do you guys remember the difference between interval notation and set builder notation? Stuff like that. So this domain looks like this in interval notation, right? This domain looks like this in interval notation. This domain looks like this in interval notation. Can we write this domain in interval notation? Okay, so can I remind you? Okay, so what is the denominator not allowed to equal? 0. Who's the only person we know that can divide by 0? Chuck Norris, right? He's not in this class, so we can't do it. All right, so we say 2x plus 5. We actually go ahead and set it equal to 0 to see what would make it equal to 0. Okay, well, almost too easy for words, right? You know how to do this. You've been doing this for a while. Negative 5 halves. So I know I wrote x equals negative 5 halves because that solves that equation, but what does that tell me about negative 5 halves? It can't be there, right? It can be everywhere else, but not there. So it can go all the way to the left and all the way to the right, but just not be at negative 5 halves. So let me remind you how we do this. Negative infinity to negative 5 halves, and then again from 5 halves to positive infinity. Does that ring a bell? Yes? Okay, good. That makes me feel good. Okay, so far? So when you're doing the division, what is x not allowed to, or what is the denominator not allowed to equal? It can't equal 0. So if you do have a denominator, set it equal to 0 to see what the domain can't be, and then rewrite your domain. You okay with that? What if we would have, what if we did this and we got blah 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 in the numerator, whatever f was or g was that it asked us to, and in the denominator we got x squared plus how about 7x plus 10? Could you figure out what the domain was then, if that was the denominator? What would we do with this denominator? We'd factor it, right? My second favorite F word. We'd factor it. Okay? What are the factors of this trinomial? 5 and 2. So x plus 5 and x plus 2. So if x plus 5 and x plus 2, one of those can't, well, neither one of them can be 0, right? What would make it 0? Negative 5 and negative 2. Do you remember how to write the domain if there's two values that x is not allowed to be? Can I remind you? Okay. Negative infinity. Which one of these is lower? Negative 5. And then again from negative 5 to negative 2. And then again from negative 2 to infinity. Does that ring a bell? Good. You okay with that? Okay, so that is combinations of functions. Okay, I should have put a title on this. Sorry about that. That's 2.6. That's combinations of functions. Okay, like I said, we did that. It's just been a while and we went kind of fast over it to begin with because it's pretty easy, isn't it? Okay. The other thing that happens in 2.6 that we talked about quite a bit, but again, it's been a while, so I'd like to remind you, is composition of functions. Okay. Composition of functions, if you're not careful, looks like combinations of functions. Okay. Because it looks like this. I promise I did not just write fog. Okay, that means f of g of x. Okay, another way you might see it written is with parentheses, f of g of x. Okay, using our two values from before, f of x was 2x plus 5, and g of x is x squared plus 3. We need to talk about this real quick. Okay. Backing up just a little bit, what if I said f of 1? What would I do with that 1? If I know f of x equals 2x plus 5 and I want to find out f of 1, what do I do with that 1? Plug it in for x, right? So I start writing f, and then wherever x is, I write a 1. So I get basically 2 times 1, which is 2, plus 5, which is 7. Well, now, guys, oh, I'm sorry. I forgot to show you the other way this is written. Can I write it real fast? It looks like this. A bunch of parentheses. Okay? F of g of x. You'll see it both ways, so just be aware. Okay? But this, to me, makes it a little easier because it was f of x, now it's f of g of x. Does it make sense to you that wherever there was an x before, now I'm going to put in g of x? Okay, so f of x is 2x plus 5. Okay? F of g of x would be 2 times g of x plus 5. Is that correct? Except I know g of x, don't I? So this is really 2 times g of x, which is x squared plus 3, and then plus 5. You okay with that? Distribute here and here to get 2x squared plus 6 plus 5, which equals 2x squared plus 11. Yeah? So here's what's interesting. What if I asked you to do g of f of x? Do you think we would get the same thing? Well, let's check. G of x is x squared plus 3. G of f of x, whoops, g of f of x, come on Kingston, equals, start writing g, which is x squared plus 3, but I'm going to replace x squared with f of x squared plus 3. But I know f of x, don't I? 2x plus 5 squared plus 3. Excuse me. Well, 2x plus 5 squared, remember this? 2x plus 5 squared is 2x plus 5 times 2x plus 5, which means I've got to distribute, right? 4x squared plus 10x plus 10x plus 25. Combining my middle terms. Oh, and then I have this plus 3. I can't forget about that plus 3, right? Excuse me. 4x squared plus 20x plus 28. Are those the same? Are these two the same? Not even close, right? So did I do something wrong? No, they don't have to be the same. I'll leave it as a little bit of foreshadowing because in the next unit or the next section that we do, you'll see why we do composition of functions. Foreshadowing. Dun dun dun. Okay. So transformations is section 2.5. A little bit with domain and range, things like that. And then 2.6 is combinations of functions and composition of functions. Got it? As always, ask me questions as we go. Otherwise, get to work.